Hello and welcome back to Precalculus 1, section 3.3 on properties of logs. These properties are extremely useful in calculus, and this being pre-calculus course, it sets you up very well for something is called logarithmic differentiation, one of the most powerful derivative taking techniques. So we're going to learn three formulas, because we already covered the change of base and the conversion formula. So we're only going to talk about the three formulas, which are as follows. Number one, log base A of x times y is log base A x plus log base A y. Just need to make sure that the stream is moving. Second one is the log base A of x divided by y. What do you think? Minus. Very good. And the third formula is going to be log base A of x to some power p. P goes in front, and we have log A of x. These three formulas are extremely useful later on. We are going to use these formulas here in this class as well in the next two sections. But you really need to know these for your calculus courses later on. So we are going to have two types of problems in this section. One that will be expanding log functions, which is what we are going to use later for calculus, and one that will be compressing log functions, which will be used in our class later. So what do we do? Let's take a look at the problem, which will say expand. So this is a problem where you are going to get something like this: log base, let's say 3 of x cubed y to the 4th divided by square root of z. All right. So how do we expand this? Well, we are using these rules. You see one multiplication and one subtraction. So we are going to have this equal to log base 3 of x cubed plus log base 3 of y to the 4th, and then minus log base 3 of square root of z. So anything that was multiplied gets a plus, and anything that was divided by gets a minus. Very simple. Yes? Very good. That's the next step. The next step, we are going to take these exponents and kick them out in front of the log using rule 3. So we will have 3 log base 3 of x plus 4 log 3 base of y, and then minus 1/2 log 3 of z. So square root is the exponent half. We know that from algebra course. And this is the expanded version. Now you're going to use this a lot in calculus. We are not going to use this in problems expansion. We're going to use compression. But you need to know this for your future courses. And this is going to be obviously on the test and the final, so you got to know it. But the real reason for this is next course, Calculus 1, right? Differential equation. So one more time. There is multiplication between these two. so they are added by formula 1. There is a division sign between top and the bottom, which is a subtraction from formula 2. And then each one of the exponents, 3, 4, and 1/2, was kicked out in front of the log because of the equation 3. That's it. Now I will ask you to solve one. This section is extremely short, guys. This is it. Log base 5 of cube root of x times y to the 6th divided by z to the 4 and then x plus 3. Like that. There we go. It's fun. As Nike would say, just do it. One thing is wrong. All right. Oh, no, you can't. That goes with the group. Goes to the group. Yeah, because that's what they said in the group. Good. All right, so yeah, this one is tricky, actually. Professor. No. All right. So there is the issue with this additional x plus 3 in denominator, and I will emphasize one more time, in denominator. All right? So it's going to be log base 5 of cube root of x plus, because it's multiplication, log base 5 of y to the 6 minus, because it's divided by z to the 4, log base 5 z to the 4, and here is the great Slayer, minus again log base 5 of x plus 3. It's divided by x plus 3, right? So x plus 3, it's divided by x plus 3, therefore that's a minus as well. That minus sign there is a great Slayer on every test, so make sure you have that as a negative. Anything that is in the denominator will have a minus, anything that is in the numerator will have a plus.
Even though it's being multiplied and bound?
Yes.
So no matter what you have at the bottom, it's going to be minus.
But see, this is the part where you should understand that you should not discriminate. Because these could swap places, right? You could have x plus 3 times z to the 4th. Why would then this one have a minus sign and not the other one if we swap them? So the question is whether they are in the numerator or denominator. Yes?
It wouldn't matter how many terms there are in the denominator.
Yeah. So now we have 1/3 log base 5 of x plus 6 log base 5 of y minus 4 log base 5 of z, and finally it's just minus log 5. Guys, x plus 3 cannot be broken apart because our formula only works over factors, not over additional subtraction. This is half of the lecture. How to expand, which is what we need for calculus. Let's see what we are going to need for our class, which is either compress or condense, whatever it's used. Let me check what's used. Write as a single logarithm. That's the write as a single logarithm. So where are we going to start? Well, let's say you want to compress log base 3 of x plus 4 log base 3 of y minus 15 log base 3 of x plus 7. So now you are doing the backwards procedure. Backwards procedure says whatever is positive goes in the numerator, whatever is negative goes in the denominator. However, you first have to get rid of these numbers in front. So the first thing is to go and say log base 3x plus log base 3y to the 4th, and then minus log base 3 of x plus 7 to the 15. So now, to condense it into a single log, we have division line because there is a minus somewhere. The first number is x, the second one is y to the 4th, term. And now the bottom is x plus 7 to the 15. We have time for one more example, okay? Because I know you love it so much. Let's use one from the textbook, from homework section. It's a wonderful, wonderful example. Let's see. Oh, these are all very easy, actually. Wow. Wow. Yeah, the book has actually easier problems than what I have as the example. That's okay. Look what the book has. 3 ln x plus 5 ln y minus 6 ln z. What do we do?
Do we have to convert to log?
Nope. We can leave it as ln. What's the first step?
You have to move those numbers over.
Move the numbers in. That's good. Ln x cubed plus
ln x y cubed fifth minus 6 ln z, or ln z 6, z to 6.
You got it.
final answer.
Ln x cubed plus y to the fifth over, no, minus times y to the fifth over z.
Yes. No, he had it on a paper.
Yeah.
So the next class is quiz on this stuff, and then we'll do a 3.4.
What did you just say?
I'll see you next class.